our time, we calculated it to be 0.77 seconds. And that's all. That's what you need to draw. And there is no such a thing as practice makes perfect. Practice makes progress. Let us look at question 3 of the grade 12 final examination that was written in November 2018 as a way to measure our progress in vertical projectile motion. The first thing that we're going to do in order to break this question down is to actually start by interpreting the problem. That is the first rule that we are going to use. Part of interpreting this problem involves reading it. The problem says to us that in a competition, participants must attempt to throw a ball vertically upwards past point T, marked on a tall vertical pole. Point T is 3.7 meters above the ground. Point T may or may not be the highest point during the motion of the ball. One participant throws the ball vertically upwards at a velocity of 7.5 meters per second from a point that is 1.6 meters above the ground, as shown in the diagram below. And very important, they further add that ignore the effects of air resistance. Now let us break all this information that we are given down. We are told that we have a competition where they have designed a pole, and that pole is marked here with T at a height of 3.7, meaning from here to that mark we have a height of 3.7 meters. Now people will attempt to throw balls so that they either come below or they come at that height or above that height of T. And I believe that, if you are above the height T when you throw the ball, that's when you win in this competition. That's why we say the projectile may or may not be the highest point when you throw your ball. Now, in this situation, we have a ball being thrown, possibly by a participant here at a height of 1.2. So they start throwing it here with a velocity of 7.5. Now, for me to write down all this information down or to give labels to it and draw my vectors, I'm going to choose my direction using the reference frame, where I'm saying any vector that goes vertically upwards is actually positive. Now, this velocity here would be the initial velocity that the participant throws the ball with. And the height that they throw this ball at, I'll just call it change in y initial, because that's the initial height where the ball is located when they throw it, is our position or the displacement where the ball is at. Now, I would also like to label this height where we have marked T as HT. I'm just going to label it HT, just so if I were to able to use it in the calculations on the questions that are coming, if they are ever ask me, I'm able to distinguish it from this height here or even any other height that I may calculate. The other important statement is that we should ignore the effects of air friction. That would mean that we have here the force of gravity being the only force that acts in this situation, and we all know that the force of gravity always points vertically downwards towards the center of the earth, because if we ignore a resistance, it means there are no any other forces. But we know that this force is directly proportional to the acceleration, so this would mean that our acceleration would actually be A is equals to G is equals to negative 9.8 meters per second squared, because I've chosen up as positive and this goes down. So this statement means that our acceleration will be a constant 9.8. The other thing that maybe I may draw is to say that when this ball is thrown vertically upwards with a velocity of 7.5, it will make a trajectory or a path such that maybe it will come here and come back, or it will move from this point and continue past this point and maybe reach this point and come down, or it will continue going up and exceed this point. So there are these three general possibilities with this ball, hence we say it may or may not. So we don't know because, you know, we are not given that height, but we know that it moves with this velocity. So we are to judge in our calculations possibly if this velocity will make it to reach this height or that height or even that height. I'm done with interpreting my problem. The next thing that I'm going to do is that I am going to classify this problem as a problem that relates really well to vertical projectile motion. And the reason I'm saying that is because I saw a lot of vertically upwards, vertically upwards, just like that, and ignore air resistance. All those things were giving me a hint that we are going to deal with vertical projectile motion. And I mean, if there's no air resistance, we said our acceleration is constant, and we know that when the acceleration is constant, we can use the equations of motion. So for me, this is a problem that requires the knowledge of vertical projectile motion, where we're going to use the equations of motion and also perhaps even draw graphs from those equations. You can classify this problem to belong to any other part of physics. That's also fine, but I think my interest is to actually assist you to practice vertical projectile motion. So this was classifying the problem. The third thing that I'm going to do is actually then go answer the questions. Now, in answering these questions, we are going to jump straight to question 3.1, which says to us that in which direction is the net force acting on the ball while it moves towards point T. Remember, when the ball moves towards point T, it's actually going upwards. Whether it will end here or end here or end here, it is actually going upwards towards that point T. Now we are asked here, what is the net force as it moves upwards like that? Well, we know that there are no any other forces, and the only force acting is the force of gravity. That means that if I were to define my net force by adding all the forces that are acting on this object, I will have here the net force to be equal to the force of gravity, right? So I'll add the force of gravity, but there's no any other forces to add here, so I'll just have to add 0, 0, because there are no any other forces. Remember, there's no air resistance, there's no any other external forces. This means that the net force is exactly the force of gravity. It is the only force that is acting in this situation. Even if the ball is going up, it is the only force that is acting in this situation. In fact, that is the reason why this ball will actually slow down as it goes upwards, meaning at some point here at the maximum height or here, we will actually have the velocity, I'll call it velocity final, because here we have the initial velocity to be 0 meters per second. So this tells you that as this ball goes upward, it is actually slowing down. Why? Because the force is going downwards. I remember when I explained this topic in our lesson, the first lesson actually, I said that imagine that it's you running towards this direction. Let's say you are running towards this direction with some velocity v, and there is someone who is pulling you with a force towards that direction, and this is the only force acting on you. What would happen eventually with you is that you will slow down, your velocity will get smaller. As you go towards that direction, your velocity will get smaller until such a time where you will actually stop when you get here. Because of this force, it's sort of dragging you in the opposite direction. That's exactly what's happening here. The object is going up with velocities that are getting smaller and smaller because there's a force that is pulling this ball downwards like that. Just a refresher on what we studied in lesson 1. So that is to say, that is the only force that is acting here. Right. Now, we are given options here to say choose from upwards or downwards, right? Obviously, we can see that when we answer question 3, we will actually here at 3.1 say that our force goes downwards. Our force goes downwards, and they further say to us, give a reason for your answer. Now, to give a reason here, we will say here that the only force present is actually the force of gravity. And it always, all the time, points downwards. This force will always point in the downward direction towards the center of the earth. That's your reason. I mean, we spoke about it to say this force will always go vertically downwards towards the center of the earth. That's why even the acceleration goes downwards. And in fact, you can reason with the acceleration. You can say the acceleration always goes downwards. That will also be accepted because they are directly proportional, these two. Now, I'm going to navigate my answer. This is what we call conceptual question. It's a question that requires your understanding of concepts. So to navigate this answer means we check if our answer is correct, if there's no errors, if the spellings are correct when we have a conceptual question, because we're only writing in words here. So I can have a look at my answer to see if everything is okay. I'm saying here that the only force present is the force of gravity, and it always points downwards towards the center of the earth. That looks good to me, and I can see how I'm going to get the full 2 marks. 1 mark for writing downwards and 1 mark for providing the explanation. That was a good question to revise vertical projectile motion. Now we're going to move to question 3.2, where they say calculate the time taken by the ball to reach the highest point. Now we want to know what time will the ball take to reach the maximum height, meaning how long will it take the ball to get to this, or to get to this, or to get to that. What is, in all these cases, what is the time, the change in time? Because remember, we don't know if it's below at t or above t. So in all these 3 cases, what is the time? Because all of this, they mark the maximum point. Now that means I'm going to go to question 3.2. To answer this equation, I'm going to choose the equation that says final velocity is equals to initial velocity plus the acceleration times time. Because I realized that I actually have my final velocity here, I have my initial velocity, and I have g as well. Those are the three things that I have on my equation. Now the final velocity is 0 because it's the velocity at the maximum height, and this object starts moving at 7.5 plus negative 9.8 times change in t. So this means I'm going to have a negative 7.5 because I'm taking this to this side, it's going to be negative, and I'm left with negative 9.8 times change in t. Now if I divide both sides by negative 9.8, I am at a position where now I'm only left with the time this side, and I can pull my calculator to then calculate the answer by saying 7.5 divided by negative 9.8, and this actually gives me a time of 0.77 seconds. So we're saying therefore our time would be 0.77 seconds. Now this is a calculation problem, and we can navigate this answer to see if it makes sense. First thing first, I see there's no errors here. I've calculated the change in t, I've written SI units and the number. And also when I look at my number, is extremely small, and that makes sense because if you look at the height that I'm competing with here, the 3.7 and even above, it's a very small height, you know. We can even estimate 4 here because after 3.7 we get into 4, maybe 5 meters. You are able to, especially if you are moving you are changing your position or your distance at the rate of 7.5 meters for every second, we can actually achieve that time. So that is navigating our answer to see if it sort of makes sense, and this is out of 3 marks. So the 3 marks will come from this formula substitution and the final answer. Now we'll jump to the next question, which is 3.3, that says determine by means of calculation whether the ball will pass point T or not. Now what we are saying here is that we need to show using calculations whether our ball will be here, will be at T, or it will be above T. So this is another way of asking us to calculate the maximum point or the maximum height, right? Because if we take this initial velocity and the final velocity and the acceleration due to gravity, we are able to find the maximum height, and the value that we get will either be below T or above T, or even perhaps at T. So it means we have to compare the value that we get to this height of T after calculating it. So I'm going to do exactly that. Now to do that, we are going to jump straight to question 3.3, and I'm really going to use the equation that says the final velocity squared is equals to the initial velocity squared plus twice the acceleration times change in y. Now our velocity final is 0 because it is at the maximum point, and we begin our motion with the 7.5 squared, and here we have 2 times 9.8, and we are trying to get this height here. Now I just want to do a couple of important labelings here. So what we are actually looking for is the height from here to either here or here or here, and I'm going to call that height the change in y, is what is in the formula here. But the maximum height would be from here to any of these heights here. So this distance from here to here or here will be defined by change in y max. Remember, I don't know if this thing will be below, at T, or above T, but either one of those will give me the maximum height, meaning I need to add this height and the height that I get here or here, or that one that is above. Now, the one that we are calculating here would be the one that starts at the 1.6. So now to calculate this, we are going to use our calculator now to say that the 7.5 squared actually gives us 56.25, and we know that 0 squared is just 0, and here we are going to have a negative 19.6, and we have the change in y. If I take this 56.25 this side, I get negative 56.25 to be equal to negative 19.6 change in y. Now when we divide by 19.6 here and 19.6 here, we will really be left this side with the change in y, because the 19.6 will cancel, and then I can determine the answer now by punching the calculator. And this says here that we are going to have a 2.8698 and so on. Now notice that I'm not rounding off my answer here because it is not the final answer. Remember, the change in y is either this height or this height or that height. This is the change in y here. But we actually need the height from here to here, or here, or here, which is the change in x max. And we are saying that that height, the change in y max, will be defined by change in y initial plus change in y. Now what I'm saying here is that if I take this height, change in y initial, and I add this height here, change in y, which would either be this or that, I should get this maximum height. Now this means here I'm going to have the 1.6 plus the 2.8698. And when I punch this on my calculator, I am going to say answer plus 1.6. Okay, this calculator, I don't know what is it doing. So I'm going to have 1.6 plus 2.8698, and that actually gives me a height of 4.47. So we get a height of, we're saying therefore the maximum height is actually 4.47 meters. Now look at this. We are saying from here going up, we're going to get a height of 4.47. Now 4.7 already is above this 3.7. It's actually a height probably even exceeding the pole, I'm not sure, but at least it is above this point T. So this means that we can modify perhaps our diagrams to say these parts here are not relevant anymore. These parts here are not relevant anymore because the true motion of the ball is that it will move and exceed the T and go to 4.47, right? And so basically I was adding this plus that, which is this here, and it gave me the whole length of that maximum. So that is part of problem navigation. I'm sort of navigating my answer. The other way to navigate this answer really is to check if I've calculated everything. I've written the correct symbol here, I've written the number and the SI unit. Now this question is marked out of 6 marks. The 1 mark will come from using the correct formula, substituting the left hand side, the 0 there, and substituting the right hand side, meaning the whole thing here on the right hand side, and getting this value here of the first height above the 1.6, and that is like 4 marks. The last 2 marks will come from answering the question. Remember, they wanted us to determine if the ball will actually past t or not. So I haven't really answered this question. It's very important to answer this question. So to answer this question, I'm going to say here that since our change in y max, the maximum height that the ball has is actually given by 4.47 and is greater than ht, which is 3.7 meters, right? So what am I saying in this statement? I'm saying that our maximum height is 4.47 and is bigger than ht, is bigger than this height. So this height here is bigger than this height, right? And this height is defined by 3.7. Therefore, if that's the case, we clearly can see that it means the ball has passed t and went above t, right? Therefore, the ball will actually pass point t. So the other 2 marks actually comes from writing this statement. They will give you a mark really for saying this here, to say our maximum height is bigger than the mark t, and because it's bigger than that, it therefore can be concluded that the ball passes that point. So that's where the other 2 marks come from, and you get your total of 6 marks. Let us jump to the last question, which is question 3.4. Now this question says draw a velocity versus time graph for the motion of the ball from the instant it is thrown upwards until it reaches the maximum point. Now what we're saying here is that we are only interested from where we throw the ball until it reaches this maximum height. Remember, we now know that the maximum height is here. We don't care about when it comes down here. We don't want you to draw any section of that motion. Now to do that, and in fact that's why this question, when you look at it, is 2 marks, because our graph is not a full graph really. So we are going to quickly jump to question 3.4, where we are drawing a velocity versus time graph. And the first thing that I'm going to do is to recognize the fact that when you draw a velocity versus time graph, we actually use the equation v final is equals to a times change in t plus v initial. Now this is just the equation of motion, one of our equations of motion. And when you look at this equation, you can see that it's a straight line graph. That means when we draw a graph using this equation, it's going to be a straight line graph. And the a here would be the gradient in my straight line graph, and the vi here would be the y-intercept, meaning that's where the graph will intercept the y-axis. Now here our gradient is given by negative 9.8 because we chose up as positive, and our projectile actually has that negative 9.8 here. And also our y-intercept here, the initial velocity is 7.5 meters per second, and it's positive because it goes upwards. That's all I need in order for me to draw my graph. Now if you don't understand what I'm saying and what I'm doing, I'll advise that you quickly go to the playlist of the lessons in vertical projectile motion, where I explain all these graphs, and be sure that you know what we are doing here. So we're saying the y-intercept would be a point here which is 7.5, and we know that when our slope is actually negative, we have a graph that goes downhill like that. A negative slope, which means our graph goes down like that. So the graph will intercept the y-axis at the point of 7.5, and it will go down like that. However, I'm going to stop this graph here because the question says we must only show when it goes upwards until the maximum position or the maximum height, maximum point. And I'm stopping here because we know that this graph actually should go down until this point. But we know that from here to here represents the upward motion. We discussed that when we did our graphs. And this part here represents the downward motion. So we are not interested in the downward motion in this question. Now, from drawing this graph, I can then put other values that I'm missing. If you look at this, you can see that the velocity actually starts being 7.5 and gets smaller and smaller and smaller until we get to this point here where the velocity is 0. And obviously, that is a typical projectile motion. We are having the velocity of 7.5 and it's getting smaller, getting smaller, getting smaller until a point where we are at a velocity of 0. And at that point, our time, we calculated it to be 0.77 seconds. And that's all. That's what you need to draw in this situation. Now, this is a very simple graph that they're going to give you a mark for drawing this, for writing the time and also the initial velocity. So basically, they are marking what they requested you to do for 2 marks.